important topic that is related to power supply and connectors. So as you know, you being an electronic students, and probably this is the lecture which is more or less electronics and less as such on computer. And another reason behind taking this particular topic in detail is that, see, if you say any electronic equipment, for that matter it could be TV or it can be a desktop computer, it can be monitor or DVD recorder or any other electronic gadgets whatever you have, which actually runs on a power supply. So here you will need every electronic gadget will have its own power supply. So nowadays, if that particular gadgets requires a very large power, I mean, most of the time voltage you require is less, but the current requirements are very large. And to satisfy this and to have a very high efficiency, the normally power supply used is the switch mode power supply that is called as SMPS. In fact, there are two types of power supply. What you have studied so far, or in also you are going to, in fact, produce or you are going to, mm, in whenever you will be doing your project. Hello, can you hear me? आवाज येतोय ना माझा?
Yes, sir.
हॅलो.
Yes,
हां,
sir.
पण प्लीज तुमचा मायक्रोफोन म्यूट करून ठेवा. Anyway, if you have got any difficulties related to this, I'll say you can you can unmute your microphone and you can ask me even during my lectures also if you have any problems. Now, as I said, for your projects, you have to fabricate or you have to create or you have to design a power supply for almost every students. That power supply normally your voltage regulators or what we call as a linear power supply. So there is a basic difference between linear power supply and switch mode power supply. And in fact, switch mode power supplies are normally used in almost all the electronic gadgets which require somewhat a larger power. So let us see, today we'll discuss this. If you see, this is the box that is at the top left corner. So this is 630 watts electronic SMPS power supply. As you say, it is also an ATX power supply. So if you see at the back side of it, you'll see there is a, at the same time, that is C24 connector. Below that there is a on-off switch. Nowadays that on-off switch normally is not available on your machines. We'll see later on details the different parts of this particular SMPS. And I have also decided to take one practical demonstration of this, explaining what is exactly each part of this. So that I'll cover later on. Then on the right side, this you will find 20 pin Molex connector. That is a 20 pin ATX power supply connector, which is actually connected to the motherboard, which we have already seen. Then that is another question which I have asked you. That is 80 power supply, which contain 20 pins, and how to identify this or how to insert this. If you collect these two black wires, uh, say close to each other, and then you can vertically insert this. So that was the old power supply, 80 power supply. And apart, there are different connectors, power supply connectors, which are of a different sizes and different varieties. And the most popular one are these two. That is two Molex type of connector. These are the most type of. This is more popular connector if you see in motherboards which are available, say maybe in India. These are the connectors which are used. Let's see, now we'll go ahead with this. Now if you see the very first, that is what are the wire color codes are there. So there are different wires having a specific colors. If you say black, that will be for ground. Orange, that is 3.3, which is normally given to your memory, that is power volts, power supply. Then plus 5 volt, which is actually needed everywhere, is plus 5 volt supply, especially for your CPU. Then plus 12 volts and minus 12 volt, these are yellow and blue wires. These are normally required for your DVD power supply as well as your HDD. So for DVD and HDD, these are the normally we require. Then this is a green power supply, green pin, that is green wire, which is a very important wire. Which is used to give the power onto the supply. So once you connect this particular power supply, then we'll see this particular wire, because you can connect this green wire and ground, then only your actually SMPS starts. Then this is a purple, that is we say this is a 5 volt standby supply. That means even if you switch off your machines, then here you normally find a red indicator, red LED glowing, and that is called as a standby supply, which if not on desktop machine, it is normally available onto your TV or monitors and similar gadgets. So this is the what we call as a 5 volt standby supply. Then this is the most important voltage, that is a gray wire code, that is called as a power good signal. As I said, when you switch on the SMPS at that time, when 5 volt is stable, then only that 5 volt stable supply is given to the motherboard, and that indication or that signal is given through this particular pin, that is called as a power good signal. Then similarly, there is a plus 3.3 volt sense, and in additional wire, this is the additional connections in 20 and 24 pin connectors. And this white pin, which was in old power supply units, that is minus 5 volt, nowadays that you do not require, but it is still given in 20 volt connector as well as 24 uh, volt 24 pin connector of SMPS. Let us say these are the different colors, and these colors, if you know or if you remember, it will help you in diagnosing your power supply as well as connecting the different power supplies to the different devices. Now, what is the role of power supply as such? So here it should give a very stable power supply. Another important is that this is a as when the power is given inside a cabinet, you will find there is a lot of devices. Being a semiconductor devices, that some heat is going to be distributed. So to keep these all semiconductor devices cool, normally SMPS provides a fan, and it takes care of the cooling part. Another important part here, that your power supply should be efficient. Efficient, I mean there should be very less wastage of power in the form of heat, or maybe that all the power that is taken by your supply, it should be utilized to the 100%. That means efficiency should be very high as possible. Then expandability is one of the factor, that whatever the SMPS, even if you add in future some of the devices in your uh, say desktop unit, then in that case you should able to give a supply or that expandability of this drive, or either rather even the wattages are increased, these wattages should also be taken up by your uh, SMPS. So that is another requirement. So as commonly we can say about 30 to 40% problems that come into computer, these are actually responsible, our power supply is responsible for this 28% of the computer problem. And the cost of this is very less, at hardly you can say 2% of the computer cost. So this is the cheaper relatively. There is a lot of advancement is there, and as it is manufactured in a large, so obviously the cost of this is very less. So maybe if you see this 630 SMPS which I have shown to you, it will go in the market, it will cost hardly 450 to 550 rupees. Let's say now today I'm going to compare what is the linear power supply, and then what is the SMPS as such, then what are the working of this, and then today we'll go in little bit details about the linear power supply and how it is designed and how it works. Once you understand this linear power supply, then I feel it will be very easy for you to understand the exact working of SMPS. Let's see, for this linear power supply, you can give the AC input, that is 230 volts, which is normally given to C4 at the back end of your SMPS unit. Once this power is given to this power could be 110 volt or it can be 240 depending upon the country or whatever the conventional main power supply you have. Normally we have 230 or 240, that is the standard input voltage available. Then in linear power supply, what we do, normally this AC voltage that is converted into a that AC, high AC is converted into relatively low AC. And that is done by using what is called as an input transformer. So usually we use 12012 or 909 or like that. These type of step down transformers are used here. This is decrease your voltages, that is 230 volt is converted into 9 volt or 12 volt AC. That means this is AC to AC conversion. Once this low voltage AC is obtained, then that is given to your standard rectifiers, which you may have a full wave bridge rectifier or normally a full wave rectifier or a bridge rectifier. Normally, as you know, bridge rectifier has a better advantage. So mostly power linear power supply will consist of bridge rectifiers. Once this rectifier is there, that means you'll have some DC voltage available, but this will be a pulsating DC, as you know. To smooth out, to have a very stable output voltage, you will have to have some smoothing circuitry. That smoothing circuitry is in the form of filters, which can be pipe filters or mostly LC filters, which will give you the very stable output voltage. At the same time, if there is any ripple or any pulsating DC, that will be removed from this by the use of filter circuitry, and ultimately you will get what is the desired voltage, that 5 volts, 9 volts or 12 volts, that is available there, and from this voltage is given to the entire circuitry. So this is what we called about, this is about the linear power supply. Then when we talk about the switch mode power supply, see now there is a basic difference between linear power supply and switch mode power supply. If you see the first stage is the same, that is AC input. That input, instead of giving it to the AC transformer, it is actually given to the input rectifier and filter. That means a high voltage, that is high AC voltage, is converted into again high DC voltages. Remember, this here stage it is directly rectifier and filter is used. So here obviously diode ratings, these are that these diodes are withstand to your 230 volts as against to their rectifier, which works at a very low AC voltage, but it works at a very high DC voltage. And you have studied already the regulators. So once we have AC is converted into DC, then you know that the DC voltages are relatively higher than the incoming AC voltage. That is peak DC voltage. Whatever the peak DC voltage will get, that is nothing but the root 2 times the input RMS voltage, input AC voltage. So if you have a 230 volts, then that if you multiply it by 1.412, then that will become almost 315 to 320 DC voltage. That means from this high AC voltage, high DC voltage is obtained first. Then this high DC voltage, which given to your bulk capacitor or backup capacitor, that we normally call as a buck capacitor, which is a very large capacitor. And that capacitor actually gives the fixed DC voltages. And then where we use a critical circuit that called the inverter or chopper. That is normally called as DC to DC converter. I hope you have studied power electronics. And in power electronics, you also have studied these chopper circuits. So this chopper circuit, input to this chopper circuit is normally your what we'll say a square wave or a rectangular wave. That is normally, and here duty cycle of that particular wave can be controlled or can be changed. Now the reason is that why we are going for DC to DC chopper, not we are relying on your linear power supply, because if you use DC to DC chopper, there are a lot of advantages of this circuit. Very first, this particular circuit is work almost at 50 kilohertz or 100 kilohertz, and due to this higher frequency, you will find that the whatever the core that is required or the transformer that is designed, it is normally we use high frequency ferrite cores, and as the frequency increases, the design or later on we'll study that the size of the transformer gets reduced. So main advantage of SMPS is that it will give a lot of high currents to you, maybe in the form of 12 amperes, 13 ampere, 20 amperes. But this large current you will get without increasing the size of the transformer. That is the main advantage of using this. Then once this is chopped down, that means this will be these high DC voltages, that is a pulsating DC voltages, which will be controlled by this chopper controller. In fact, the output from this DC to DC chopper, it will be again it will get a high DC voltages, and that will be obtained from a ferrite core large transformer. It is very similar to the conventional transformer, but the design of this transformer is different. And remember, and it has got a, it is normally called as a high voltage transformer. And then from this, whatever the DC voltages it gets, that is unregulated DC voltage, that unregulated DC voltage is further regulated and further again based on your requirement. Normally you require 12 volts, minus 12 volts, 5 volt, 3.3 volts, or for normally again power supply nowadays, you also get 5 volt stabilized supply for charging your USB, that is USB charger. That is this type of three voltages you normally require at the output, that is 12, 5 and 3.3. So at the output you will find there will be three diodes operating 12 volts, maybe 5 volts and 3 volts. These diode rectifiers along with filters will take care of giving you the best possible, best stabilized DC supply. And if there is any variation into this DC voltage, actually some error signal is generated from the output in the form of and this error signal through optocoupler, it is given to your chopper controller. Normally chopper controller in SMPS you will find there is a one typical IC. There are up 5 to 6 ICs are there which are commonly used into this. But here this chopper controller is a specific IC. Based on the error signal, it either increases the duty cycles of the chopper circuit, that is DC to DC converter, and ultimately based on your output is increased, then error signal will be given appropriately so that the output will be automatically decreased through this feedback mechanism. So this is in short what we called as an working of a switch mode power supply. So here at this stage you must understand what is the difference between the two as far as operation is concerned. So we'll find why the switch mode power supply, the name is given. This is simply because we are switching the high voltage that is generated from this rectifier and filter which is available at the bulk capacitor. That voltage is switched at a very high frequency. As I said, it is 15 to 100, and for that we use a switching transistor. Here for this switching transistor, mostly nowadays FET is used, which actually switches or makes on and off the circuitry at a very fast rate. And if you find if this is operating at such a fast rate, whatever the output voltage generated by this, it will based on, it will be depend upon the duty cycle. If you want to decrease this, then you have to increase the, you have to decrease the duty cycle. If you increase the duty cycle, ultimately output of this circuit will increase. So here what is the advantage here? It is that you'll find here there is a very high efficiency of this SMPS. So in short, in next slide we'll compare what is a switch mode power supply and regular linear power supply. So here this operation I have already told you how this particular circuit operates. So let's go to this particular comparison. Then here as the definition itself, it completes the stepping down of AC voltage first and then it converts it into DC. That means as we said in linear power, we use a transformer which converts 230 AC into 9 or 12 volt AC only. That means it converts AC to AC and then rectifier is used to convert into DC. But as against to this linear power supply in switch mode, what we do, it converts the input signal into DC. That means AC is converted into DC. Then DC is chopped down. That means this unregulated DC is again converted into regulated DC, that is by using a chopper circuit. And that is why in chopper circuit, actually we use the FET, that is a switching transistor, as this action switches very fast. That is why the name is given as switch mode power supply. If you see efficiency of this linear power supply, it is hardly 20 to 25%. As against to this 60, 65, or even you can reach to 70 to 80% of this particular efficiency is very high. Then voltage regulation, we'll see what is the regulation. You know already what is voltage regulation. That means your output voltage should remain constant in spite of any changes in the input voltage. That we call as a voltage regulation. And this is done by voltage regulator, regulating action, That we'll see now today what how this voltage regulatory action takes place inside a linear power supply. And this voltage regulation is done by a feedback circuit which you have just seen, which consists of optocoupler and and here we'll have a controller IC that is actually controls what is called as a pulse width modulation. If you control that width of a pulse, it is actually a pulse width modulator and which actually controls the width and ultimately the power delivered by from this. Then if you see the transformers used in respective power supplies, here you will find steli or the steel and alloy and otherwise this CRGO, cold rolled grain oriented steel. It is normally used as a core of the transformer, but against to that SMPS works at a very fast rate, and for this fast rate we use normally ferroid core which works at a very efficiently at a very high frequency. Another difference is that linear power supply, as far as its reliability is concerned, this is more reliable. SMPS, of course, it also gives the better responses, but it is more or less depends upon the transistor and FET for its switching action. Complexity, it is very less complex. There is no complex requirement as such in linear power supply because circuit is very straightforward. Here as we are introduce the switching components and high frequency ferrites and maybe as we are generating the very RF noise and EMF noise, so circuit goes to overcome this, the circuit becomes more complex. Then transient response, it is faster response. It is a slow response. That means if there is any transient voltage is there, that it will have a very fast response that will suddenly drop down. But here it will have some problems with transient. Of course, to take care of transients, these metal oxide varistors are used in the SMPS. Then when it comes to RF interference, there is no RF interference, but here RF shielding has to be provided as switching produces more RF interference. Because this switching, when you say 50 kilohertz or 100 kilohertz, that comes into your radio frequency range. So you have to this switching noise has to be filtered out. So here there is RF interference. Then noise and electromagnetic interference, as far as in linear power supply, there is no problem as such. It is, but here again because of switching noises that is created, so EMI interference is there. So you reduce this particular noise. You have to use what is called as EMI filters in switch mode power supply. As far as applications are concerned, it is used in audio frequency and radio frequency application, mostly AC to AC converter, and for low power voltage regulators. This is normally used what we use in LM317 or 87805 ICs. That is normally if you want 5 to 10 voltage requirements and current requirements are less, maybe about 1 or 2 amperes. If that is the maximum current requirement voltage, then we go for low power applications for linear power supply. But it is used for charging of mobiles whatever you have. It is used in DC motors as well as other applications. You can say the HDTV or whatever the big TVs, or we are coming with LED TVs and all this, or even the uh, monitor of your desktop monitor or a display unit of the computers, or as I said, it may be DVD players or even audio systems or or even desktop or SMPS. All everywhere, wherever your power requirements are large. I mean, current requirements are large. It is better, and if you want a low voltages, maybe up to 10 volts, 12 volts, even 50 volts with a higher, larger current, then SMPS is the best solution. So these are the some differences between linear power supply and switch mode power supply. Then what are the devices that are normally form the parts of SMPS? So obviously output capacitor, as I said, this is a large bulk capacitor which maintains the higher DC voltage, stable DC voltage. Now here, as heat, as it is produces a large amount of heat, so here you'll have to use what is you will be using a large current requirements. So obviously power transistors are used, and for these power transistors to dissipate the heat, you need to use what is called as the heat sinks. Then it is another function of a power supply, that is cooling. So it is provided by attaching a fans to it. Then as I said, there are two types of interference normally generated here, RF interference and electromagnetic interference. So you have to use EMI filter circuits. Then line conditioning circuitry. Whenever I mean line conditioning means your input voltage should be stable. It should be about 230 volts. If there is any spikes, surges, etc. are coming into your AC mains voltage, then you have to eliminate or reduce the effect of this. So that line conditioning circuitry is required. So we'll see these line conditioning circuit details when we'll study the SMPS circuitry. Then another important is circuit is introduced into SMPS circuit, that is called as a power factor correction circuit. So PFC circuit. What exactly power factor correction means what? See, if you see the power factor, I will say that if you calculate the DC wattage, DC wattage is normally given by the voltage into current. So whatever the voltage into current, if you directly multiply, you will get what is called as a DC wattage. But if you want AC output power or AC wattage, these AC wattage are normally given by a current into voltage into power factor. And this power factor is a value which lies between 0 to 1. Why this power factor correction is needed? That is just because if your current signal is not in synchronous with the voltages, that means current and voltages, if there is a phase shift between these two waveforms, then you will find that there is a power factor is introduced into it. Normally power factor whatever we get from MACB or similar line, this power factor is 0.7, 0.8 like that. That means here AC, but normally there is no power factor correction is applied to your MACB meter because that is calculated kilowatts per hour, that is calculated, and that is not calculated like this. So here this is a circuit which, and now remember, in nowadays power factor correction is employed or a compulsory or mandatory in all the SMPS coming into the market. That power factor correction is of two types. It can be passive power factor correction, or it can be active power factor corrections. So here whenever you say active power factor corrections, here you will have to use circuitry. On the passive factor correction, it can be done by attaching either capacitor or inductor in parallel with the transformer. It is possible to reduce this power factor or raise the power factor, maybe from certain lower value to higher value, to just increase the output AC wattages. Then there will be certain input capacitors will be there, and there will be many other components will be there, like what we say, there can be a NTC, RF filters, EMI filters, or maybe Schottky diodes, optocouplers, and as some ICs for controlling these. So these are the major components of your any computer power supply parts. Then coming to the next is that, like we have seen what is form factor, we have seen a form factor for motherboard. So as we said, form factor is the actually the size of the motherboard, maybe dimension, length and width. Whatever be that size is, we call that is a power factor of motherboard. On similar line, there are power factors defined for power supply units too. Then one may say why these power factors are defined. Just because these are the some 8, say 6, 7 power factors are given. If you say that my power factor is CFX 12 volt, that means compact form factor. That means for this particular power factor, the length and the width of your power supply unit is fixed. And accordingly, that power factor, even if you want to purchase any power supply, if your power supply is gone down, and if you have a very good let us say if you have some server machines or non-standard desktop machines are there, or maybe slim machines are there, then in that case you have to specify what is the size of your SMPS unit. So that unit size is the given by the term called as form factor, or we'll say this is power supply form factor. There are four major power supply factors, that is ATX 12 volt version 1.x, then ATX 12 volt version 2.x, Here ATX 12 volt may have a 20 pins, ATX 12 volt may have 24 pins. Then another factor is micro ATX. Then some of the power factors, because most of the manufacturers like Intel, AMD or other even device manufacturer or desktop manufacturers, they specify their form factors into their specifications. So that means if you required to order any PSU unit, that is power supply unit, then you must consider what is the power factor of that particular power supply unit. And it will be it can be LFX 12 volt, that is low profile, SFX small power factor, then EPS 12 volt, that is the power factor used for server motherboards having 8 extra pin connector. Then you can have a CFX 12 volt, that is compact form factor, then TFX 12 volt, that is thin form factor, WTX 12 volt, that is used for workstation form factor, high end workstation servers it is used. Then another is the Flex ATX, it is the form factor which is still used in some of the desktop machine having less than 3 expansion slots on the motherboard. So this is the meaning of form factor as applicable to power supply. It will give you the exact size of your power supply unit. That's what can be a. There are three sizes as such. It can be have a length as well as width and as well as it will have a height. So because this is a cubical part, so when it is a cubical part, you require to specify the exact size because that size is actually uh, that size, considering that size actually your I'll say the desktop size or server size or a box of that is actually designed motherboard, that what we say that is generally a unit of that is designed based on this particular factor. Hope I you are now here understood what is mean by power supply form factors and probably how it is different from a motherboard form factors. Now this is the connector, as we said, these are the two types of connector. Top one, if you see this particular connector is, as you know, it is a ATX 20 pin connector, and against to that this is a 12 pin connector, that is 80 pin connector. If you see the connections of these wires, these are normally called as a P8 and P9 connector. P8 and P9 is connected together with these black wires is taken close to this black wire and vertically these are inserted into those 12 pin sockets. So if you see the voltages available of this 80 style uh, power supply unit. So here as usual these are the conventional, this is the power good signal. As we find there is also power good signal, but that was in gray color in 20, but it is in orange color in old. Then this is 5 volt supply, this is similar supply plus 5 volt plus 12 volt minus 12 volt. For in 80 power supply, they all the memories used were requiring a 5 volt supply or maybe minus 12 volt supply plus 12. So there was no requirement of a specific 3.3 volts. And in old motherboards also you required to use a minus 5 volts because some of the slots were requiring these particular voltages, old slots. That is why these are the pin connections. Now you can see exactly that if you see these particular connections, now I can say these are nothing. First pin is power good, then this plus 5 volt, this is plus 12 volt, then minus 12 volt, and these are the two ground pins. Similarly, these are the two ground pin 1 2. That means 1 2 3 4 5 6 7 8 9 10 11 12, like that. These are the connections, and on similar line this is connection is for this particular P8 connector, and these connections are starting from this to P9 connector. So this is for 80 connector style. Probably you don't require to connect this particular connector because it will be used in very old motherboards which are almost outdated in the market today. So this is the two types of connectors. Advanced connector, as we say, this is the ATX pin connector. It is 20 pin connector and 24 pin connector, and the respective voltages are given, the respective colors are given. At the same time, then even if you require to measure the voltages, you can take a multimeter and across this 20 pin connector, you can directly measure the voltages, but only For measuring these particular voltages, you have to make your power supply on, and you can make your power supply on only when you short this particular 4 number wire, that is the green wire. This green wire has to be, that is PS on. This green wire has to be shorted with any black wire. If these wires are shorted, then only your fan will start. Otherwise, your fan will never start. And if it is not, if power start signal is not given, then SMPS will not work. So this is the very first. If you remove your power supply, and after removing power supply from your computer unit, and if you want to measure the individual voltage, always short these two pins. That is the green pin and black pin, and then all the voltages and expected voltages will be available at this. Even if you say 12 volt, it can be 12.12 or it can be 11.5, 11.6 like this. But relatively, it will be a very stable voltages. Maybe this variation may cause because of your output voltage might have some variation, or your multimeter may have some offset voltages. The, hopefully these voltages are always stable. So this is related to 20 pin connector, and another is nowadays in ATX we have got additional, these 24 pin connectors are there because of the additional power supply you require to give to your Pentium processor. So normally these next 4 connectors are directly connected to your CPU, or some are mostly it is connected to CPU as an additional power supply. Then see, these are the individual voltages, what it actually been consumed by in, these are the individual voltages, I will say, the what each component requires, what are the wattages of every device takes. So if you talk about AGP, it takes 20 to 30 volts. PCI's card, if it is there, it will take 5 volts. Then if you have a SCSI hard disk, it will take 40 to 25 watts. Floppy disk drive, nowadays there is no floppy disk drive, but it is consumed 5 watts. Network card 4 watts. CD-ROM 10 to 25 watts. Then RAM is taking 10 watts to 10 watts per 120 megabytes. That is the, it will based on your RAM chip. But nowadays, as you said, DDR chips are so it is so efficient. These are related taking a very less power. Then PC, then hard disk, which may take 5 to 15 watts. Motherboard will take about 20 to 30 watts. Then processor, of whichever the processor we use, that processor will take a different packages. So here, see, Athlon a 600 mm Athlon processor, it will take 45 watts. This is the AMD processors. Other processors are Intel processors. Intel processors are taking relatively a lesser voltages. So I mean, see, probably you may have, if I ask you the question, something like that, if you wanted to purchase a SMPS, what should be the rating, or how I should purchase this SMPS? So if you see, then most of the times for today's desktop units, if you have a SMPS about 500 to 600 watts, that is sufficient, because there is a your it hardly your desktop units hardly take 300 to 350 or 400 watts. But even if some additional devices are connected to your uh, desktop unit, even it is possible that it will still take your power, that is 550, 600, if it is designed for 600 watts. And if in certain cases, if power requirements are large, then it is possible that your control circuitry can increase your output power based on the requirements. If your supply unit or your say desktop units demands more power, it is the responsibility of SMPS to give the additional power to those particular device. So that is why it is normally designed at a higher wattages. And as I said, up to 500 and 600 wattage it is sufficient. But some of the power supplies you may find in server or other systems where two motherboards are there, or it can be multiple devices will be there. In that case, you may have a power board of 800 watts, 1000 watts, and even 2000 watts power. So SMPS power supplies are available. Of course, that will be dedicated for those particular high energy requirement devices only. So this is all the component that takes. Now within next 10-15 minutes, I will try to explain you how your linear power supply works. Hopefully you know these operations. but I'm from electronics point of view, I'm going to revise these particular concepts. So here, as this is the again the same uh, block diagram which I have explained to you. Let's go step by step that how your linear power supply works. So let us say for this, if I wanted to use this as a voltage regulator, then you will require a 12 volt DC supply, then one switch and probably another load. Here a load will be in the form of bulb. Initially as the switch is open, so there will not be current, and the switch as switch is open, the light will be off. Now for this, if I wanted to just glow this particular light, I need to press that particular switch on. If a switch is made on, then entire voltage will be applied across that particular bulb. And due to this particular voltage, you will find this lamp will glow or a light will glow. Then now the question is that if this light is glowing okay, then how to change the intensity of the bulb? Let us say if I wanted to glow this particular bulb with 6 volt, then what I'll need to do, there are two options obviously for this to 6 volt. One may say that instead of 12 volt battery, you connect the 6 volt battery. But does it a good solution? Obviously not, because if you want a variable supply output voltage, not every time you are not going to switch between the batteries. You should have a one same battery, and from that battery you should able to derive the desired voltages. So how to decrease the voltage that is applied across the bulb? So if you want to decrease the voltage, solution is that you have to have certain voltage drop across this. So best voltage drop across you can get by using what we call as an resistor. If you connect one resistor across this, then depending upon this, let us say if you want to have an, let's say, if the same battery is obvious, as I said, you cannot, there are two solutions, but changing a battery is not a better solution. So you must change the voltage that can be applied across the load. That is the required voltages. So best solution is that you must have certain voltage drop. So that will depend upon what is the current flowing through this, and at the same time what is now the how much value is required. So if you know the voltage, okay, then here obviously you can decide what is the current requirement, and if you know certain that if you know say what how much voltage drop you required. So let us say if you want to have a 6 voltage drop, then here you can decide what is the value of current and resistance. So by multiplying I and R, you can get the required value of resistor that should be connected to this, so that it will give you the voltage drop of 6 volt, and then only that 6 volt will be applied like in this particular circuitry. Okay, so here, if you want half of the intensity, then obviously you have to reduce the 6 voltage from the applied voltages. That means if you need, let us say, if you need one third of the input of a light across the load, that means if you want to, instead of half intensity, if you wanted to go for one third of the original intensity, then again you have to increase this particular voltage drop. So here in this case you require to have 12 volt by 3, that will give 4 volt. That means you at the output lamp should have only 4 voltage across this. Then you need to dissipate, or you have to drop this particular voltage by 8 volts. Then if you go by this way, what are the limitations of this particular circuitry? So limitations of this particular circuitry, obviously the very large amount of voltage you are trying to drop, and this will be in the form of, if you go for this, there will be a, first thing, it is a wastage of power, because you are requiring only 4 volt DC, and then 8 volt DC you are wasting. And to waste, that means first is a wastage of power, second this power is wasted in the form of heat. So obviously it more heat will be generated. So when more heat will be generated, obviously you will require to have a cooling. That is the disadvantage of this particular regulator. But more disadvantage on this regulator side is that if there is, it is possible when you say you have a battery, this 12 volt battery, it could be lithium battery or any, over age or after certain time, this battery initially it could be very fully charged, it can be 14 volts, or over a period of time it may go to 11 volt or even a 12 volt. At that time, whatever be the calculations that you have done before applying this particular register, that will mess up. That means this calculation will no longer be correct now, and then obviously in that case you cannot have an exact 4 voltage that will be applied across the load. This is because if your input voltage increases, then you'll have to require to have a very high voltage drop. That means in this case, let us talk about this particular case. If there is a 14 volt fully charged, then obviously this instead of 8 volt DC, now in that case you will have to produce 10 volt or 20 volt voltage drop. But if it is somewhat undercharged, that is 11 volt, then in that case, that voltage drop should be only 7 volt. That means the fixed resistors will not serve the purpose in this particular circuit. So best if there is any voltage variations, then you must have a certain variable resistors, and then by variable these resistors, you should be in a position to vary these particular resistors, and then after varying this resistance, then only you can keep your output voltage constant. So here, how you can have this particular facility available before going to this particular solution. This is another solution that is normally employed in case of voltage regulator. That is, we normally use what is called as an Zener diode. So here, if you use Zener diode, then what happens here mostly, if there is any increase in the voltage, that increase in the voltage, obviously there will be increase in the current, and so that here in any, the property of Zener diode is that any increase in the voltage will be converted into current, and actually this will be converted into current, and it will ensure that it will ensure that the output voltage across Zener, that is, it is reverse bias cathode to anode, that voltage will be exactly for which it is designed. Let us say we have to see the catalog and we have to select the Zener. If you want 4 voltage at the output, then that 4 voltage Zener has to be connected as a reverse bias across that particular load. So even if there is any voltage variations, that voltage variations will be compensated by this particular Zener diode. That means you can get certain, even if your input voltages are varying, you will get the constant voltage at the output. But mostly the limitations of this Zener circuitry is that Zener diode is normally designed for 3 to 5 watts only. Here I have said voltages, but it is designed for watts, 3 to 5 watts only. Then if you want to have a higher wattages rating of Zener diode, it becomes costly. So this is not going to be a good solution for higher current requirement, because you need to have a, in SMPS we require to have a very higher current, or if you have a voltage regulator where current requirement are high, then probably this particular circuit arrangement will fail. Then another disadvantage of this circuitry is that if you use this particular circuitry and if you change the voltage right from 10 volts to 15 volts, and if you note down the voltage across the load step by step, then you will find that initially for a 10, 11, 12 volts, output could be exactly 4 volts. But if output voltage becomes 13, 14, 15, then in that case, because of the Zener, then properties of the Zener, the output voltage may not be exactly 4, but it will may change to 4.1, 4.2 or similar like that. So that means there is some, if the input voltage is variation, then output voltage, though the proportionate deviation may be very small, as your input voltage is switching from 10 volt to 15 volt. For 5 volt variation, here whole output variations will be hardly zero point 0.2 volts. But it still there is a variation. That means if input voltage is changed from 10 volt to 15 volts, their output voltage is varying from 4 to 4.42. That means output deviation is hardly zero point 0.2 volts. But when I say hardly, that means still there is a change in the output voltage. So we do not want this output voltage to be changed. Then what is the best solution to this? Probably the best solution is that now we require the variable resistor. Now, if you wanted to have a variable resistor, then the best way you can use here power transistor as a variable variable resistor across the two terminals. So here what is done normally, instead of uh, use this switch, now we can remove that particular switch, and then you can have this particular power transistor with collector connected to the input side and emitter is connected to the load. That is, this becomes your emitter follower circuit. Now if you want these voltages to be obtained, let us say if you want certain only 4 voltages should be given to DC, then in that case you can apply the base driving voltages. You can adjust these base driving voltages in such a way that what will be the voltage drop that is across this collector to emitter terminal, it will be about 8 volts. That means there is a variable resistance is there between collector to emitter terminal, and that variable resistance, how much value of this variable resistance, it will be entirely dependent upon the how much uh, base voltages you are providing. So we can say base acts as a driving signal, and it can be at the base of a transistor. This driving signal can be set in such a way that the required voltage drop can be obtained. So probably this is the better solution than what we are using earlier. Then how it is to be implemented? So here in this case also, if there is a 14 volts input, then in that case again you will have to produce the voltage drop across collector to emitter is of 10 volts. Okay, then if the voltage is decreased, then in that case collector to emitter voltage will require 7 volt. Then how it can be possible? Just change the base drive voltage. Another advantage of this circuitry is that not only for volt, but if you want some variable voltages across the output, it is possible by changing the base drive voltages. You can have a variable voltages across the output. That means if a input voltage is varying with time, now the question is that if the input voltage is varying with time, then how to produce a stable driving voltage that is going to base of the transistor. That means if input is varying with over the time, then how you can have a stable voltage at the base. This stable voltage at the base can be obtained by modifying the earlier circuit. If you see this, probably you have studied this in basic or and especially in applied electronics. What is this voltage regulator or how this voltage regulator works? So here, how this particular circuit works. So to provide us constant base drive, fixed base drive, so that if a stable voltage input is there, we should have a stable output voltage. Then your base drive should be constant or stable. Then here we use a fixed resistor along with zener, and then whatever be the this particular at this particular point, we will get what we the fixed voltage that is called as the reference voltage. And if you adjust this particular reference voltage, you will get the fixed voltages at the output. So this is the modified arrangement that is done in this case in and most of the voltage regulator IC. For that matter, take the one which we normally use for LM317 or maybe 7805. Okay, so for this 7805, you get exactly 5 voltage at down. Even for this LM37, what is done is if you open this particular circuitry or you open this particular IC, then you'll find there will be zener inbuilt into. That zener and fixed register will give the fixed reference voltage, and with these fixed reference voltages, you can have certain voltages. You can adjust this. So for this, you normally have three pins. These three pins can be shown here as input pin, output pin, and ground pin. Then these three pins you can connect into your circuit, and you can apply certain voltages at the input. Whatever the voltages at the input, the same then desired voltages that the desired voltage is either maybe 5 volts or 20 volts or 9 volts, that accordingly you change that your IC, but you'll find inside there will be zener diode, there will be fixed resistor, mostly there will be a power transistor which will be in the form of heat sink and all this. That heat sink will be actually connected to that particular IC, and this way this voltage regulation actually takes place. That means here we get the output exactly the desired voltages, and that will be fixed voltage. There will be very less changes in the voltage, but still if you go for the analyzing of this particular circuitry, you'll find there is still some output variations. If their input voltage varies, output voltage is not remaining stable. It do have certain variation. If you really want to remove all these variations, and if you really want to have the output voltage perfectly constant in spite of variations in the input voltage, then the only solution left to you is that you have to use what is called as a feedback mechanism. And this particular feedback mechanism can be employed into this such a voltage regulator by using this particular circuit. So here, what is done here? you get certain fixed reference voltages that is obtained from this, and then you also get the output voltages. So whatever the output voltages is given as a one input to your comparator amplifier, another is a V reference, that is you may say these are the op amp, and this is actually using as a, it is acting as an error amplifier. So if there is any variations in the voltages, let us say if the output voltage is increased, then that increased voltages will be there in applied to one in reference. So that means there will be more error. So if there is a more error, then in that case, then this will decrease the base drive. When the base drive will be decreased, automatically you will find the registers across collector emitter will be increased, and if that is increased, that will, the more voltage drop will be there, and ultimately whatever the increased voltage, that will be compensated by using this. So this is what we called as an voltage regulator with feedback mechanism. So I hope by giving this series of circuits, hopefully you have understood now what is exactly voltage regulator and how voltage is kept constant in spite of variations in this. But as we said, the limitation of this particular circuitry is that it can be used only for low voltage output. Of course, now if you go for this error amplifier and all this and in markets, these ICs are available. So this actually gives you, with this particular mechanism, it regulates the voltage. This type of voltage regulation is called as okay, let us say I'll stop here today, and tomorrow or maybe on Monday, I'll start with the switch mode power supply. Then we'll go to the certain definitions of power supply that is connected with this. Many terms are there. Once study then what are the solutions and how is SMPS is designed, how it can be protected, and maybe if time permits, we'll go for some of the typical faults available in power supply and how this can be removed. So this is all about in today's lecture. If you have got any difficulties, your difficulties as usual, these are welcome. बोल ना, आज का है difficulty?